Algebra 2 students, we are going to continue looking at the unit circle. Here's a blank one. And we are going to define something that you have heard me talk about for the year, but now you will finally know. The definition of 1 radian. The radian, or 1 radian, is the length of the arc on the unit circle. When we talk about radians, a radian is the length of the arc on the unit circle. So I'll get rid of the 1. We're measuring angles by the length of this arc. Now we understand the unit circle has a radius of 1, and for any concentric circle with a larger radius, the length of the arc would be different, but the degree measure of the arc would be the same, and the radian measure of the arc is the length of that arc on the unit circle, a length of the arc swept out by that angle on the unit circle. So let's take the entire length of the circle. It's also known as the circumference. So what's the entire circle length? It's 2 pi, because the radius is 1. That's what makes it the unit circle. So this is 0, and if I go all the way around the circle in radians, I would call that 2 pi. Now radians have no units. In math, if you see an angle and there's no units associated with it, you should associate that as a as a radian measurement. If I go halfway around the circle, that's where we get pi. If I go a quarter of the way of the circle, I get 2 pi divided by 4. That's why I get pi halves. If I go 3/4 of the circle, I get 3/4 times 2 pi, and I get 3 pi over 2. Now, all of these other measurements I can find using geometry. So this angle right here is 30 degrees. It's also 30 degrees divided by 360, whatever that unit in radians is, to 2 pi. Whatever it is in degrees to the whole circle, whatever it is in radians to the whole circle in radians. And I can solve here. And you end up getting pi divided by 6. Now I'm going to use that pi divided by 6. That's the length of this arc. And the mathematician just defines the radian measure of an angle is the length of the arc for the same angle on the unit circle. So now I'm just going to add that length again here, and I'm going to get 2 pi 6, which reduces. I'm going to add it again. I'll get 3 pi 6. I'll add it again and get 4 pi 6, which reduces. I'll add it again and get 5 pi 6, 6 pi 6, 7 pi 6, 8 pi 6, 9 pi 6, 10 pi 6, 11 pi 6, and 12 pi 6. So just like I did with the angles, 30, 60, 90, 120, 150, 180, 210, 240, 270, 300, 330, 360. I just added 30 degrees around and walked around the unit circle. I can do the same with the radian measure. Good? I can then do this with the other angle here. I could set up this ratio. 45 degrees is to 360. What x is to 2 pi. And if you solve that, and in terms of pi, notice the degrees cancel over here, you'll get that this is pi force. And I'll do the exact same thing. Pi force is this arc. If I add the length of that arc, I'm here and I'm at 2 pi force, 3 pi force, 4 pi force, 5 pi force, 6 pi force, 7 pi force, and 8 pi force. So all the radian is, for when we talk about the radian measure of an angle, we think about whatever that angle would be on the unit circle, and the radian measure of that angle is the length of the arc. These are the special angles between 0 and 2 pi that correspond to angles between 0 and 360 that most high school mathematicians memorize. I want you to memorize them because it's just helpful. Notice that there's a helpful conversion factor that 2 pi equals 360 degrees. Divide by 2 and you get pi equals 180 degrees. So here's the conversion factor. Pi radians equals 180 degrees. Because pi is a transcendental number that goes on forever, right, with no pattern, irrational number. Maybe not transcendental. I'll have to look up that definition. I may have misspoke. Sorry. Got to remind myself what that means. But because pi is irrational, that any nice degree, like 30 degrees, is going to correspond to a irrational radian that we'll write in terms of pi. Just like 1 radian, which is a nice radian, corresponds to 180 degrees divided by pi, which ends up being like 57 something degrees. So there's a misconception that kids have, and that's that radians have to involve pi. They don't. All the nice angles will involve pi, but all the nice radians, the degrees will involve pi, and they'll be ugly. So that's kind of just how it goes. Generally, when we talk about the radian measures of angles, we're looking at these special angles. So your work tonight is to go around the unit circle that you've been looking at and add all of these radian measures to it and start to review, how did I produce the unit circle? How do I produce the XY values? How did I produce the angles? How did I get the radian measures of those angles? You can use this conversion factor to go between radians and degrees. And that's really it. All right. Have a good night. Peace.